comes to coating concrete, the general rule of thumb is to wait at least 28 days for the concrete to cure before applying a coating system. But where does that rule come from? And are there ways to get around the rule in situations when you're working on a fast-track project or working with green concrete? Hello, and thank you for joining us for the latest edition of Coatings Decoded. I'm Mark Thomas, and today I'm joined by Vaughn O'Day, Sales Director at Tennema Company for Water and Wastewater Treatment. Welcome, Vaughn.
Thanks, Mark.
So we're going to talk about concrete and some of the complexities of coating concrete. And one of the things, if you're involved in the construction industry at all and involved with using concrete or dealing with concrete, you hear about this 28-day cure requirement. It seems like a really specific time frame before you can get back on concrete. And where did that 28 days come from?
Yeah, Mark. So that 28-day waiting period for new cast in place Portland cement concrete is certainly a controversial topic within the coatings industry and really requires consideration of the design of that particular concrete structure. And what I mean by that is we need to consider, is this a slab on grade element? Is this a liquid containing structure found in waterworks? We need to better understand the design and the use of that structure before we can either flatly dismiss this 28-day waiting period or we comply. So first, let me start with kind of the origin of that 28-day waiting period. And it really came from the civil engineering aspect of construction. That benchmark originated as a requirement to determine when Portland cement concrete achieves its full design compressive strength, as well as used as a marker for the constructor to determine when they can terminate curing of newly placed Portland cement concrete. So that 4-week waiting period was adopted by the protective coatings industry because it usually allows enough time for Portland cement concrete to achieve that full strength and hydration. This 28-day waiting period was then transposed again onto that concept that the concrete has cured because it's fully hydrated, and that excess water of convenience that is added, and water of convenience is that amount of water that is added to the batch to allow the constructor to place the material, to give it the fluidity. That waiting period allows that water of convenience to evaporate out of the concrete element, so as it doesn't cause a premature failure of a protective coating applied to fresh concrete. So not only are we worried about the water of convenience that's in that mix, but we're also worried about the dimensional changes that Portland cement concrete undergoes during that curing period, during that 28-day time frame, if you will. And Portland cement concrete is known to shrink and contract as it undergoes this curing and hardening. So we're also worried about the restrained shrinkage that occurs in the cracking, the restrained shrinkage cracking that occurs within this cure period. So that's, again, just kind of a basic background of the 28-day cure, the origin, and some of the major concerns that we're worried about.
So if you're going to coat concrete, you've got to make sure it's fully hydrolyzed, it's fully cured, it's done what it wants to do. And that 28-day mark seems a bit like kind of a general guideline the industry's adopted over the years. So what happens if you can't wait 28 days? If you have a construction schedule or return to service time that you've got to get something coated and back in service, but you can't wait that benchmark time of 28 days, what options do you have?
And Mark, that circumstance does come up on occasion, just due to fast track schedules and the like. They just can't wait for that 28, 30 days or so for that concrete to fully hydrate, and they have to get on it quicker. Again, you need to consider the design of the element itself. And I use that slab on grade as an example in a design case number one, where that slab will likely have some expansion joints, maybe some contraction joints built into the design to allow for that cracking to occur. As long as your moisture content, that water of convenience, as long as that moisture content is within the tolerances of that protective lining, and the design team and all parties understand that the cracking can still occur. Usually it's forced over to those contraction joints. Then usually there's really no problem. Again, we can test for moisture using some ASTM tests. There's a plastic sheet method. There's a relative humidity in situ probe method. There's a calcium chloride a method as well. So as long as the moisture content falls within the tolerances of the products, and the design parties, the construction parties, all understand the risk of cracking that may occur, then by all means, we can coat prior to that 28 days. When it comes to liquid containing structures, they typically design those in restraint, meaning there's not typically expansion joints. We usually don't design for contraction. There will be construction joints with water stops, and the design concept is to force all cracking to those joints and to maintain that liquid tightness. Unfortunately, there's a lot of restraint built in because of the foundations that are offering restraint, just the adjacent elements, and then a tremendous amount of reinforcing steel. So what we end up with is random shrinkage cracking that occurs, and that cracking isn't always forced over to the construction joints as designed. So the risk there, Mark, is if you coat prior to that 28 days, again, provided your moisture levels are within the tolerance of that particular coating or lining, you could have some random shrinkage cracks that transfer up through the lining system. Those can be repaired, but all parties need to understand the risks associated with coating that concrete prior to that full 28 days. And it's been my experience, Mark, if the concrete structure is curing at about 75 degrees or greater, usually that restrained shrinkage cracking occurs within that first 30 days or so. Doesn't mean that it's terminated and no cracking, no additional cracking will occur, but it usually cracks within the first 30 days.
So you talked about the importance of making sure that it's fully cured or cured to the point where it's within the recommendations of the coating system that's going over it. And you listed off 3 different test methods to determine if there's moisture present. Out of those 3, is there one that the coatings industry or to name it company specifically really prefers or recommends versus the other 2?
Well, again, Mark, it's going to depend on the design of the concrete structure. If it's a slab on grade, then we can use the calcium chloride. That's very common. The in situ probe that measures relative humidity is also commonly used on horizontal surfaces. For vertical surfaces, we're limited to just 2 of those. Plastic sheet is a very common qualitative test. Relative humidity in situ probe can also be used. And obviously for vertical surfaces, the calcium chloride cannot. So just in general, we recommend all 3 as a way to measure for the presence of moisture in that concrete. And if it falls below the allowable threshold, then in most cases our linings can go over top. In the event that we have excess moisture, there are primer systems that can be applied to the concrete that can help withstand either the high alkalinity associated with that less than 28-day age material, or the higher moisture vapor transmission levels, again, caused from that water of convenience coming out of the element.
There's a term that gets thrown around, green concrete, and I hear it in reference to maybe newly placed concrete. But can you describe exactly what people mean by green concrete, and are there other connotations that could be misconstrued?
Mark, that's a tough one. It really is. Traditionally, green concrete did refer to that less than 28-day aged structure. And so that's the old traditional connotation of green concrete. But we are seeing the usage of green concrete to describe more of a recycled concrete that contains, say, old pulverized concrete in lieu of a traditional aggregate. They're using ground up concrete material. So you have to be careful when using that term green concrete or answering questions to that term green concrete, because it can have different meanings, depending on the specific connotation. So I like to refer to it as less than 28-day aged concrete to describe concrete that has not fully hydrated. That's probably a more accurate and safer assumption there when addressing those circumstances.
Let's go back to you previously mentioned that some coating technologies can handle the higher alkalinity with newer concrete and also the moisture vapor that might be present. How would you know if you have a primer that's in the specification that can handle that type of environment, or one that might be susceptible or intolerant to high alkalinity or high moisture vapor?
Mark, that's a really good question. And the best way to know is to consult the manufacturer. And responsible manufacturers should be testing. There are certain test methods to simulate high alkalinity scenarios, higher moisture vapor transmission levels. So hopefully the manufacturers are testing their recommended primer systems or even their lining systems if they're direct to concrete for those type of conditions. And so hopefully they know and can steer you to the appropriate primer system. If it's a moisture vapor reducer type of system, or if it's just a lining system that has high alkalinity tolerances and can withstand those forces of high alkalinity and even some excess moisture vapor transmission levels.
Okay. This entire time, we've really been talking about traditional Portland cement that you find in concrete. And are there other types of cements and that they use in concrete blends or other types of repair materials that have advantages over your traditional Portland cement?
Mark, that's a great point. We have been talking about Portland cement concrete because it's the most widely used cement utilized in construction, at least in North America. And it's relatively inexpensive. There are various types of Portland cement. You've got types 1, 2, 3, 4, and 5. And those do require different cure durations. But ultimately, Portland cement achieves its full hydration and compressive strength around that 28-day cure period at 75 degrees F. There are other cements out there that can be utilized that have some advantages over a Portland cement. For example, a sulfa-aluminate cement can be used in a repair mortar. It can also be used in concrete. And the advantages of that type of cement, a CSA, calcium sulfa-aluminate cement, is that it fully hydrates in about 24 hours versus a 28-day period. So the hydration rate, that speed, is much, much quicker than a Portland cement concrete. Now, why doesn't that cement get used more widely in construction? Because of costs. And it's not widely as available in North America. But there are other cements out there that have different properties and many advantages in many cases beyond the Portland cement concrete. So it's always important to discuss that with the manufacturers and see if there are instances where, say, a different type of cement concrete makes sense. So just to further stress the rationale for these reasons, I still think it's advisable to maintain the traditional minimum 28-day waiting period for cast in place Portland cement concrete, and to quantify the moisture requirements to determine that adequate cure prior.
All right, good. Well, hopefully this podcast helped to shed a little bit of light on where this 28-day rule came from, what options you have if you can't wait 28 days or want to ensure that you've got that fully hydrated and cured Portland cement concrete, and even some of the things to look out for if you can't wait that 28 days. You might have some other options as far as repair materials as well. So, Vaughn, I appreciate your time today. Thanks for joining us.
Yeah, thank you, Mark.
And we appreciate everything that you provided.
Thank you.
In the end, concrete is a tricky substrate. Because it is cured with water and can allow moisture to move within it, determining when it can be coated can be difficult. Your best bet, like any other coating project, is to contact your local Tnemec representative early on and throughout the project. For more information about our concrete coating products or to get in touch with us, please visit Tnemec.com.